Okay, let's solve this general chemistry 2 problem. A scientist prepared a 0.039 m NH4Cl salt solution by dissolving the solid salt in water. Calculate the pH at 25 degrees for the solution given Kb of ammonia NH3 is 1.8 times 10 to the negative 5. So let's start off by figuring out how NH4Cl dissociates. And this will be NH4 plus Cl minus. When H2O interacts with this, we know that Cl minus, so H2O plus Cl minus turns into HCl plus OH minus. We know that Cl minus is the conjugate base of a strong acid, HCl, and this does not significantly affect the pH because it is a strong acid. So therefore, when we look at, let's try NH4. NH4 plus H2O turns into, produces NH3 because the H, it donates an H plus to the H2O. So it would be NH3 plus H3O plus. And this looks more of what we want because we are given the NH3. But since this is an acid dissociation, because we're dissociating NH4, which is an acid, that means we must convert the Kb into Ka. We know that Kb times Ka is equal to Kw. That's one of the formulas that we should know. Okay, so let's calculate that first. So we know that Kw is 1.0 times 10 to the negative 14, and we have Kb, which is 1.8 times 10 to the negative 5 times Ka. So when we divide 1.8 times 10 to the negative 5, we get, let's see, we get that Ka is equal to 5.55, well, let's just round it to 5.6 times 10 to the negative 10. So now that we have that, we could go work on our ice table. So I, C, E, and we are given that since we're using the NH4, remember, this basically shows us that we got to plug that in for NH4 right here. So we have 0.039 molarity, so 0.039, and they didn't give us anything else. So this will be 0, this will be 0. Remember, water is liquid, therefore we exclude this. I like to usually draw dotted lines right here to remind myself that the difference between the products and the reactants. So let's do the ice table. And since, of course, we've done a lot of ice tables, we know that this will be minus x, and then this will be plus x, because, of course, it's going to shift towards the right side since there's nothing on the right side, and we're adding stuff on the reactant side, which in Le Chatelier's principle, it says that the things will shift towards the product side. So we have 0.039 minus x, and x. So when we put this, of course, it will be k squared over 0.039 minus x is equal to our new Ka value, which is 5.56 times 10 to the negative 10. So since this is a very small number right here, we could do the small x approximation, which means that we can forget about this x existence. So now that we forget about that, we could do times, we can multiply both sides by 0.039 times 0.039, which when we do this, we get, let's see, 0.039, 2.1684 times 10 to the negative 11 equals x squared. We take the square root of both sides, so we get that when we take the square root of both sides, we will get 4.66 times 10 to the negative 6 equals x. And we know that therefore this equals that, and that equals that. But the question is asking for calculate the pH. So that's not our answer. We didn't get our answer yet. When they say calculate the pH, we know that, of course, pH is equal to negative log of the H3O plus concentration, which is also molarity, which is what we have here, molarity. And therefore, we could plug this in right here because we saw that there is 4.66 times 10 to the negative 6 hydronium ions. So pH equals to negative log of 4.66 times 10 to the negative 6. And we get, let's try that out, negative log of 4.66. We get around 5.33. pH equals 5.33. When we go back here, you can see that, there we go, 5.33. And of course, 5.33 because look how many sig figs there are. There's 3 sig figs in total, therefore meaning that there should be 3 sig figs in our answer, right here. Thank you.